Shukla. Today we'll be analyzing constant velocity motion. This is Lab 1, Physics 2211. Introduction. So the objective for this lab was to analyze the motion of an object moving at constant velocity using video tracking and computational modeling. Key physics principles used were Newton's first law and Newton's second law. Some of the important formulas to be noted were position update formula and the velocity update formula. Experiment setup. So the object used was a rolling car object on a smooth table. The camera was vertically overhead and fixed, and the video was uploaded on Tracker for analysis, and GlowScript was used for computational analysis. Some of the assumptions made were the object moves at constant velocity, that is, friction and air resistance are negligible. The camera and perspective do not distort the motion, and the normal force equals to the gravitational force, and we're only considering motion along the x-axis, that is where we aren't observing any motion along the y and the z-axis. So we uploaded the video on a Tracker, and here's the video itself. So the data we obtained from Tracker was the initial position of the object, which is negative 0.00160400, which is approximately 0, as you can see. So we just assumed it to be 0. The initial velocity, which was, so to find the initial velocity, we took the position from the Tracker graph that is closest to t equals to 0, because that would give us the initial velocity. We didn't want to use average velocity because that would consider velocity across the entire motion of the object, and we know friction would slow down the object towards the end. So the computational model in VPython, the ball's position, ball's velocity, t delta t, the calculation loop. So this is the while loop that iterates to the position of the object, and based on the position, and you can see that the velocity is updated based on the velocity update formula, positions updated based on the position update formula, and the position velocity uploaded, and they're printed. So here we have the observations. On the table on the left, the left of the table on the left is the Tracker data, and the right is the computational model data. And on the right of the slide is the two graphs, the Tracker data versus the computational model data, both graphed. As you can see in the beginning, the Tracker model and the computational model almost align, but towards the end, as frictional force acts on the object, the Tracker model deviates from the computational model because it slows down the speed of the object. So follow-up questions. What if when you analyze your video data in Tracker, you made a choice of the orientation of the axes? The choice of axis orientation in Tracker affects the position and velocity data recorded. Typically, motion is tracked along the x-axis, but if the axis is flipped, position values and velocity signs will be reversed. Tracking along the y-axis instead would require adjusting calculations to reflect vertical motion. In the VPython model, these changes must be accounted for by modifying the initial position and velocity vectors to match the observed data. Discussion follow-up question number 2. What does it mean? Your observations can be predicted well by a computational model when you set the net force equals to 0 in your model. Is it possible for you to say how many pushes and pulls, that is, how many forces are being added together to give 0 net force in the case that you observe? Discuss briefly. When I set the net force 0 in my computational model, my observations almost matched the predictions. As the object kept moving, especially towards the end, its speed decreased from the initial velocity due to the force of friction. But from the graph, we can see that the computational model and the Tracker model weren't that far from each other. Assuming no friction or resistance, I can identify at least two forces at play: gravity pulling the object downward and the normal force from the surface pushing upwards. These two forces balance each other out in the vertical direction. Sources of error. So obviously there's error due to human experimenter. You may have pushed the object too hard, which made it to variable velocity rather than a constant velocity. There obviously could be a GlowScript/Tracker misuse. There may be mistakes in the computational model of the VPython code, or you may have made a mistake using the auto tracker feature in Tracker. The table may be rough as well. It could induce a greater frictional force, which would lead to a bigger deviation on the computational model. Anyway, that's it from me today. Thank you so much for watching this video, and I hope it was good. Thank you.